Hello, sorry. Okay, now it should be fine already because I use the correct laptop already. I'm so sorry for all the things that happened. I feel very, very bad. So I hope that you all are still here with me. Okay, so without further ado, let's begin, shall we? Okay, so wait a second. Teruk betul lah. I think I think I should have thrown away the laptop already. This is my second laptop actually, so that's why the new one obviously. Let's go. Yes, let's go. Let's do it. Okay. Apologize for all the things. I hope that you all still here with me. Still no audio. If still not okay, still not audio also. Okay. Okay, finally, let's go. Okay, so are you ready? Okay, so let's begin. Okay, so can you give me one moment? Okay, now, if you're already inside this one, okay, now the answer, if you can see properly, the answer is at the answer is at the this is below the link. Do you see that? Do you see that? The answer is below the link there. Okay, so I put all the answers inside there. Okay, so you can access to the answers in there. All right. Okay, so shall we? Okay, let's begin. Okay, so without further ado, let's begin our talks, shall we? Okay, so we straight away goes to this one. You can download the answer from the link below. You can see from the link YouTube there. I given actually it's the whole slide lah. It's the whole slide, and then you don't need to copy. You just need to focus. And if you have anything in the questions, so at the end of these sessions, I will have Q&A sessions for you all. Okay, and sorry for all the inconvenience caused. And throughout the lessons, if you have anything that you want to ask, feel free to ask. Okay. Sorry for all the inconvenience just now. Okay, and it takes time. Right, so let's begin. So in section A, we have 20 marks. So you are advised, students should not spend too much time in answering section A. So advisable maximum allocated time is 30 minutes. So you have that means 30 minutes for 20 questions. You only have 1 minute 30 seconds. That is the maximum time. Of course, if you can reduce it, it will be much better. And I believe that STPM, even though it's semester 2, they will also try to limit on calculation question, maybe maximum 5-6 questions out of that 20, because you cannot afford to have all the questions to be calculation. So if it comes to calculation questions and you feel that it is troublesome for you to calculate, maybe you leave it to later answer and you skip to others questions first. Okay, more theoretical questions, only then you start to answer. Okay, right, so let's discuss one by one for all the questions that I have for you. So are you ready? Okay, let's start from number 1. For an ideal gas, the plot of PV against P is a straight line. So for the real gas, such as a plot, such deviation is formed from the ideal behavior. The plot of PV against P for 3 real gas are shown below. So which represent the ammonia, hydrogen, and also nitrogens. Okay, so in here, you must know that the ideal gas line is the normal line in here. So this is the ideal gas line. Okay, so this is the ideal gas line, the straight line here. So the one which is the positive deviation is usually for hydrogen or helium. Okay, and if you look at X and Y, so this one divided more lah. So when you know that it's divided more, so it has a stronger intermolecular forces. Okay, you have a stronger intermolecular forces lah. It can be hydrogen bond and it can be anything else. So in here, we have 3 choice between ammonia, nitrogen, and also hydrogen. So in here, that is definitely NH3. This is definitely N2, and this is definitely H2, right? So the best answer in here is D, okay? Okay, so that is how you are going to answer for number 1. Huh? Okay, then it goes to number 2. In this question, you should assume that the gas form for behave as an ideal gas, 1.7 gram of the sample of magnesium react with 50 centimeter cube of 2.2 mole per decimeter cube HCl at 303 Kelvin and 110,400 Pascal. Which of the volume of gas produced measured under this condition? You are given the gas constant 8.31 joule mole minus 1 Kelvin minus 1. So you have to calculate the mole of the magnesium. So 1.7 divided by 24.3, you get 0.700 mole. And then you have mole of the HCl, so 2.2 times 10 power of negative 5, 0.05, which is actually divided by 1000 already. So you get 0.110. So your HCl required is 0.7, which is 0.14. So in other words, HCl is the limiting reagent. If you notice carefully, the HCl in here is not enough to, the HCl in here is not enough to react with the 0.77. To react with 0.77, you require 0.14. So this is not enough. So this will make the HCl to become the limiting reagent. So stoichiometrically, we have from the reaction, when we have Mg solid, okay, plus 2 HCl, okay, give MgCl2 plus H2, okay. So you can see that stoichiometrically, 2 HCl is to 1 mole of the hydrogen. So your mole of the hydrogens in here is 0.11 over 2, which is 0.0550, okay? Then you have the step 3, volume of the, using the ideal gas equation, you use PV equals to nRT, so your V is equals to nRT over P, so 0.0500 times 8.31 times 303 over 110,400. So you press your calculator, you get 1.25 decimeter cube, which is approximately 1.3 decimeter cube. Okay, so the best answer in here is A. Okay, all right. Okay, so that is how you are going to answer for question number 2. Now, if I'm going too fast or if you have any questions, please type in the comment because I can only see typing. If you want to ask on live also, I'm not sure how to do that. Okay, all right. So let's continue. Okay, so we go to number 3. The table shows the properties of the 4 solid, okay, held together by different type of the bonding. Which row describe the properties of the solid with giant covalent? So now in here, class as an additional notes in here, you must know that solid, you have 4 type of the solid, namely simple covalent molecule, simple molecule, okay, which is made of the weak van der Waals forces, the type of forces. So simple covalent molecule, okay, which is made of weak intermolecular forces or weak van der Waals, or it can also be a hydrogen bond. So both of these are. So this is one type. Then the second type is a giant covalent structure. Okay, so which is made of strong covalent bond. Okay. Sorry, by the way, what are the examples? You have H2O, you have nitrogen, you have C2H6, for example. So these are the example. Giant covalent structure, the strong covalent bond such as SiO2, carbon as in graphite. Okay. And then you have giant ionic crystal lattice. Giant ionic crystal lattice. Okay, so which is the intermolecular forces that hold in between them is a strong electrostatic attraction forces. Okay. And then finally, we have metallic structure, which is formed by metallic bond. So these are the 4 types of the solid that we have. And today we are discussing about giant covalent. So giant covalent usually has a high melting point, okay, due to the strong covalent bond throughout the structure, and usually are insoluble in polar solvent because there are no ion or polar bond interact with the solvent molecule. So and we do not conduct electricity except for graphite. So therefore, it is high melting point and insoluble in polar solvent. Right. So that is for number 3. Okay, so this is how you are going to answer for number 3. Will there be a recording for this live? Yes, you can always look back to this YouTube. Actually, in the previous year, I also already do a lot of these kind of free talks. You can revisit back all my old talks, but however, the old talks is based on old syllabus, so the new syllabus may be not suitable for you. Okay, so let's continue, shall we? Okay, number 4, the equation for the reaction between H2O2 and acidic solution of Ki is shown below. So the mechanism of the reaction is H2O2 plus I minus give H2O plus IO minus. Then you have H plus IO minus give HIO, which is a fast step. And then HIO plus H plus I minus give H2O plus I2. So which rate law for the above reactions in here? Okay, so you have rates determining step, which is a slow step, is H2O plus I minus give H2O plus IO minus. So the rate law is determined by the slow step, where rate is equals to KH2O2 times I minus. So the best answer in here is B. Okay. So this is a very straightforward questions. And then the one thing is, if the questions followed, if you can actually write an overall, get to the overall equation by comparing the between equation 1, equation 2, equation 3. So you can see you cancel IO minus, you cancel HIO, cancel HIO. So at the end you get what? You get H2O2, okay, plus 2H plus. So this is the 2H plus. You see that? Okay, plus 2I minus. Do you see that? Okay, give 2H2O, okay, which is at here, plus I2. Okay, so out of these comparisons of the mechanism steps, you can eventually get to the overall equation similarly. So students, you must be very well versed in how to write an overall ionic equation based on the mechanism steps given, and slow step is always the rate determining step. So inside here, you can straight away take the stoichiometric coefficient as the order of reaction in mechanism steps here. Okay, so we straight away goes to number 5. The data for the record of react between P and Q at a certain temperature is given below. So you have experiment P and Q and also initial rate. Okay, so which is the order of the reaction? So in order to find the rate of reaction with respect to P, you compare experiment 2 to experiment 1. So you have 2.0 times 10 power negative 3 over 0.5 times 10 power negative 3, which is equals to 4. So 4 is equals to 2 over 1 power of m lah. So your m is equals to 2. And then order of reaction with respect to Q, you compare experiment 4 to experiment 3. So 9.0 times 10 power negative 3 equals to 3, divided by 3.0 times 10 power negative 3, you get 3. So 3 over 1 is equals to n, so n is equals to 1. So overall order in here is n plus n, which is 2 plus 1. So you get third order in here. And then also worth to take notes in here is the unit of the rate constant. So you must be very, when it comes to structure and assay, you must know that for zero order, the rate constant in here is similar, mole decimeter cube per second. Okay. Then for first order, you have second minus 1. And then for second order, your rate constant unit is mole negative 1 dm cube s negative 1. Then for third order, you have a mole negative 2 dm6 s negative 1 here. All right. So that is how you are going to determine the rate. How do you determine the order of reaction? By looking at the rate constant here. Later we have questions for that. Okay, number 6. The chemical equation and the graph of decomposition for NO2 and at 573 are shown below. So this is the equation. 2NO2 give 2NO plus O2. So this is the graph. Now look carefully in here. This is a graph of rate against initial concentration. Okay, rate against concentration. So students, you have to be very familiarized with what happened to, so this rate against initial concentration is for what order? So if you know that it is for rate is equals to K for second order reaction, so you get a parabola. Okay, parabol. And then if it is a first order where rate is equals to Ka, okay, the first order. So when you plot a graph of rate against concentration of A, so you'll get a straight linear line like this, okay, and the linear line is a gradient, okay. The gradient is the rate constant, and then if you have this is for first order, And then for zero order, if you have rate against the concentration, so it is like that lah. Okay. For zero order, because rate is equals to K. Okay, so inside here you cannot measure K lah. Okay, you cannot measure the rate constant inside here. Okay, so you have to be familiarized, which is true about the decomposition. So the order of reaction is first order, which is wrong because it is a second order. So the unit of the rate constant is decimeter cube mole minus 1 second minus 1, so which is correct, B. Okay, so the gradient of the graph is the value of the rate constant because it has to determine the gradient by using this parabol. And then the value of the rate constant does not change with temperature, which is wrong because rate constant change with temperature according to the Arrhenius equations in here. So your best answer for number 5 is boy B. Okay. Okay, so let me check. Okay. So that is how you are going to answer number 5, huh? Ken? Okay. So immediately we go to question number 7. So a mixture of 2.0 sulfur dioxide and 1.0 mole of oxygen react in the presence of solid catalyst in a closed vessel at 1100 Kelvin and 9.0 kilopascal. The equation of the reaction is given below. 2SO2 plus O2 give 2SO3. If at equilibrium, 0.67 mole of SO2 is converted to SO3, what is the value of Kp? So in here, you use the ICE method lah. So what is ICE? You have initial, changes, equilibrium. So you have 2SO2 plus O2 give 2SO3. Okay, so your initial, you have 2 mole, you have 1 mole, this one is 0. But at the equation in here, at the end, 0.67 of SO2 is converted. So this one minus 0.67, this will be plus 0.67. So why? Because stoichiometrically 2 to 2, that means 1 to 1. As for this one, because O2 is also a reactant and stoichiometrically is 1 to 2, so it's half of 0.67. Okay, so at the end you get 1.33. This one you get 0.665, right? Okay, and then this one you have 0.67. Okay, so you can start to calculate already. So total mole is 1.33 plus 0.665 plus 0.67, you get 2.665 mole. So your partial pressure, so you okay, whenever you calculate Kp, here are always the steps. Use the ICE table, to help you to find the mole for each of them under equilibrium, followed by sum up the total mole. So in this case, you have 2.665, then followed by finding partial pressure for each gas. So partial pressure of SO2 and O2 and SO3 are 1.33 divided by 2.665. Times 9.0, you get 4.49 kilopascal. 0.65 divided by 2.65 times 9.0, you get 2.25 kilopascal. And then 0.67 divided by 2.665 times 9.0, you get 2.26 kilopascal. Then express Kp. So your Kp is partial pressure of SO3 squared divided by partial pressure of SO2 squared times partial pressure of O2. So you substitute 2.26 squared divided by 4.49 squared times 2.29. So you get 0.113 kilopascal negative 1 in here. Okay. So you can choose to leave your unit like that, even if it is in a structured essay question. Okay. Okay, so with that, that is how you are going to answer for number 7. Sir, can you go a bit slow? I'm so sorry. If Mr. Chu start to talk, plus I'm like talking to myself. So if I'm talking to myself, I will be like machine gun. Okay, I apologize for all inconvenience caused. And then because of the this one, if you might figure out that sometimes I cannot you cannot see some of the wording there. So as I told you, you can download the slide lah. Okay, that you can download the slide. So if you cannot catch some of the word at the corner of this presentation, so you can go to the slide and see. Sorry for I don't know. It cannot be changed. It cannot be changed to certain position. It cannot. Okay. So shall we continue? Okay. Number 8, chemical equation for a reversible reaction of NaCl and the graph reaction under various conditions are so below. Okay, so you have 2 NaCl gas, give 2 NO gas plus Cl2 gas, delta H is positive. So this is a very important keyword in here. Okay. Okay, so the curve of Q. So the curve of Q is this curve. So you must highlight, this is the main curve in here. Okay. So this is the main curve. So you are comparing the red line Q in here. Is obtained at 400 degrees Celsius and 200 kilopascal in the presence of the catalyst. Okay, if you look carefully, we have a few situations. Okay, so what are the correct conditions for PRS curve? Okay, so now you can see that we have either 300 kilopascal, 100 kilopascal. We have either 500 degrees Celsius, 200 degrees Celsius. This one also degrees Celsius. Huh? And then we have a catalyst in here. So we are going to look into one by one what happens if you have all these situation changes. So your original pressure is 200. Huh? Okay, so let's start from the pressure. So if the pressure increase, where equilibrium shift to? Equilibrium shift to the direction with less total mole of gas. So which is equilibrium will shift to the left. Okay, because left side total has 2 mole, right side total has 3 mole lah. And then if pressure decrease, okay, so your equilibrium will shift to the right, shift to more mole lah. Okay, more total mole of gas. Because of the space constraint, I cannot write everything, so you understand. Okay, 500 shift to the right. Okay, okay. Then you study in terms of temperature. So our original is 400 degrees Celsius, right? Okay, so it is 400 degrees Celsius. Okay, so when temperature increase, so equilibrium will shift to the direction of the endothermic. Okay, so because forward reaction is endo, so equilibrium shift to the right. Okay, then if temperature decrease, so equilibrium will shift to the exothermic. Therefore, equilibrium shift to the left here. Okay, okay. So now look back at the P in here. So the P says that if you look carefully at the graph P, the graph P in here shows that the resulting concentration of the NOCl at the end of the day is where P has lesser NOCl dissociate. Okay, P has lesser NOCl. That means where is equilibrium shifting? So equilibrium actually shift to left. Okay, equilibrium shift to the left. So as we deduce based on all this theory, which one suits to the description that equilibrium shift to the left? So you can see that it's either high pressure and also low temperature, isn't it? So from here, you can already see that this one fits the description. This one also fits the description. This one does not. This one also does not. Catalyst can only speed up the reaction, but not changing the amount of the product, does not change the yield, right? Okay, then you look at R here. So R here, if you look carefully in here, that they still end at the same line here, but R has a steeper gradient or steeper line in here, isn't it? Okay, steeper. Okay. So if steeper means that the rate increase. So what increase the rate? It is the catalyst. So not because of the, okay, of course, temperature can also increase the rate, yes. However, at the same time, if you increase the temperature, equilibrium shift to the right, which is endothermic. Therefore, more NOCl will also dissociate. So which completely fits the description inside S, because not only that, it become more steep, okay? At the same time, you have more NOCl dissociate. So the best description that fits all these three in here is PQ and PRS is A in here, okay? So, sir, can I ask if half of the volume have equilibrium will shift where? Half the volume of the vessel will cause pressure to increase. Okay, will cause pressure to increase. So if pressure increase, so based on the deduction, equilibrium shift to the direction with less total mole of gas. Okay. Okay. Yes, the answer is A. Correct. Very good. Okay. So shall we continue? Yeah. Okay. So that is number 8. Then we go to number 9. So number 9 says that in an equilibrium system, two separate experiments are carried out under different conditions. One of the experiments is carried out with an increasing pressure and constant temperature, while the other experiment is carried out by decreasing temperature and constant pressure, which equilibrium cause an increase in the yield of both experiments. Okay, so in here, if you want to increase the pressure, so equilibrium will shift to the side with fewer gas of mole. Okay. And then if you decrease the temperature, equilibrium will shift towards the exothermic. Okay, so now because you want equilibrium to shift the right, correct? Because you want to increase the yield, so you must make the equilibrium shift to right. So if you want to shift to right, so forward reaction in terms of pressure, so this one is 4 mole. You see in A, this one is 4 mole, this one is 2 mole. If you look at B, this one is 2 mole, this one also 2 mole. You look at C, this one 1 mole, this one is 2 mole. You look at D, this one 2 mole, this one also 2 mole. Of course, O2 is gas. Sorry for the typing error. Okay, so which is the best that fits in the description in here? So as you can see that, the A, yes, right side has less total mole. And then B, the forward reaction is exothermic. So both increase the yield in here. Okay. So that is why A is the answer. As for B, changing the pressure has no effect because both have the same side. However, lower the temperature will lower the product. So equilibrium shift to the right also. However, A fits in the description better. As for C, increase the phasor pressure will make the equilibrium shift to the left because the left side has lesser mole. And then increasing the temperature will cause equilibrium to shift to the left because endothermic forward reaction. And then finally for D, pressure has no effect and lowering the temperature will favor to the left. Okay, so the best answer in here is A. Okay, so that is for number 9. Okay, so it goes to number 10, shall we? Okay. Okay, so a sparingly soluble MOHX is added to a little quantities repeatedly in water. Which of the following is not true about the reaction? A. Solubility product is KSP MX plus OH minus X. Okay. Saturated solution is formed when OH minus is equal to MX plus. Solution is in equilibrium with undissolved solid, and the solubility of the salt MOHX reduced with the addition of NaOH. So let's together understand. So when you write the dissociation equation, it goes by MOHX reversibly MX plus XOH. If in the structure and assay, state of matter is a mass. You must write this is AQ. Okay, this is AQ. Okay, this is solid. Okay. So in terms of solubility, S amount of the MOH will dissociate S amount of MX plus and XS amount of the OH minus in here. Okay. So in terms of the KSP, so KSP is MX plus times OH minus power of X, which is true. And then for B, OH minus is equals to N minus is not necessarily true for the saturated because OH minus is equals to XMN plus. So in another word, if let's say now, today your OH is 2 so you dissociate to become 1M2 plus and 2 OH minus, right? So S will become S and 2S. So now, if you say that concentration of N2 plus is equals to the concentration of the OH minus, so it's S to S. In your KSP is equals to S times 2S squared. which is equals to 4s cubed. Now, this one is Q. We are now Q, not KSP. For the mixing in B, it is Q. So Q equals to S times S. Okay, S times S. So it's equals to S squared. So since your Q is lesser than KSP, so that is why you not yet achieve the saturated solution. So B is wrong. Okay. C, solution is in equilibrium with the undissolved solid, which is correct, because when we talk about solubility product, it's in between the solid. Okay, if you have solution, it's in between the solid and also the aqueous ion solution in here. Okay, and then solubility of the MOH is reduced by the NaOH, which is true, because when you increase the concentration of OH minus due to the common ion effect, equilibrium shift to the left, hence reduce the solubility. So the best answer in here is B. Okay. Okay, just now I see, sir, for question 7, why the total pressure will not decrease when the total mole changes from 3 to 2.67? The pressure will still remain the same. Okay, the pressure will still, because this is under the P total lah. The question already said P total is 9 kilopascal. Am I right? I've forgotten the question already. 9 kilopascal. So under all whatever circumstances, the total pressure will be still equals to 9. So if the number of mole changes, mole fraction changes. So mole fraction changes means that partial pressure of each gas changes. So it's still, at the end, you still get 9 kilopascal. Just that the composition is different already. Okay. Okay, so I go back. Okay, so that is for number 10. So any questions so far? Can I? All right. So if no question, then let's continue to this one. Number 11, shall we? Okay, titration between CH3CONA and excess CH3COH produce a buffer solution, which is not true about the buffer solution. Okay, so now you are now titrating. So you are titrating CH3COONA into CH3COH. So inside this aqueous solution, what do you have? Because CH3COH is a weak acid, it will dissociate partially to become CH3COO minus and also H plus, isn't it? So inside this solution now, you not only you have CH3COO minus and also H plus, but you still have CH3COH. The moment that you add CH3COONA here, okay, okay, the moment that you add drop by drop of the CH3COH now, so you are just increasing the concentration of the CH3COOH minus, sorry, CH3CO minus and also Na plus, okay? So now you still have CH3CO minus, you still have H plus, you still have CH3COH in here, right? Okay, so which of the following is not true about the titration? A, pH is less than 7, which is correct because it is an acidic buffer solution. B, concentration of CH3CO minus decrease, which is wrong because when you add the CH3COH, you increase the concentration of the CH3CO minus. So B is wrong. C, the buffer solution consists of H plus, Na plus, CH3CO minus. Now, I wouldn't say that C is completely correct because you still lack of one thing. You still lack of one answer, which is you can also have CH3COOH. But at least you still have these three components, am I right? So C is not entirely wrong. It's just that not complete. If B is correct, then C is wrong. Okay? Then D, degree of dissociation decrease, yes, due to common ion effect. Okay? So in buffer, the presence of the CH3CO minus suppresses the dissociation of CH3COH. Therefore, the degree of dissociation also decreases a bit here, right? So the best answer, because we are looking for not true, So the best answer in here is point B. Okay. Okay, so very good. Let's continue. All right, 12. What is the pH of a buffer solution? Is 0.32 mole per decimeter cube of ammonium chloride is added to 0.500 ammonia. Now, this is a very straightforward question, huh? Because you just simply need to substitute. So your pKb is 4.74. So your pKa is equals to 14 minus pKb, which is 9.26. So using the actually, can I correct this? Because I think I terbalikly this one, huh? Okay. Okay, acid over base. Sorry, I think I this one I expressed wrongly. Yeah. Okay, can I use the this one to solve? There are two way lah. There are actually two way. Yeah. Yes, this one is correct. Yes. Okay. And then it's supposedly 0. Sorry. It's supposedly 0.50 0.50 over 0.32. Okay. Okay. So this is solving by using K, because when you have this one, so this one is the acid, this one is the base. Okay. Okay. So if you use the manual methods where you have POH is equals to pKb minus log concentration of the base over the concentration of the conjugate acid lah. Okay, so you shall have 4.74 times minus log power of 0.50 over 0.32. Okay. Okay, so press your calculator. At the end, you have 4 point how many? 4.55. Okay, so 4.55. So your pH is equals to 14 minus POH. So you have 14 minus 4.55. You have 9.45. So using this one is easier lah. Using this one is easier lah. Okay. Okay. So this is the how you are going to solve for this one. Huh? Okay, so that is for number 12. Okay, so the answer is D. So using the second method is more straightforward compared to the first one. I worry that the first one will confuse you all. So you better don't use this one. Okay. Okay, so that is for number 12. Huh? Okay, number 13. NaX and NaY are halide salt that has the lattice energy negative 776 and negative 731 kilojoule per mole respectively, which is true about the difference of the lattice energy. So this one you must know that lattice energy is directly proportional to the charge, yet inversely proportional to the inter-ionic radius. So because NaY has less negative lattice energy, so ionic bond is weaker, meaning that an ion of Y minus is larger than X minus. Okay, so A, size of Y minus is greater than X minus, which is true. A, correct. And then covalent character in NaY, the covalent character is present in NaY. This one we will discuss a little bit deeper later, which is wrong. So hydrogen bond exists between NaX, which is also wrong. And then NaY melting point has higher because you have a lower lattice energy equals to lower melting point here. Okay, a little bit that I'm going to discuss about is because one of the selection of answer that arouse our interest in here is this one, covalent characteristic. Okay, so now teacher, how when there is sometimes there's one very small subtopic inside the lattice energy here. If you buy my module and look into it lah, okay, you have a series of the value. Let's say, for example, NaCl. You have experimental value and also this theoretical value. Okay, so they give you a series like NaCl, Kf, for example. They give you negative 776 lah. Theoretical is negative 775 lah. KM. These are just example. I cannot remember the exact one. Let's say this one is 851 lah. This one is negative 852 lah. Okay, then you are to compare, let's say, with AgCl. Experimental value is, let's say, negative 861. This one theoretical value is negative 935, for example lah. And then you have ZNS. The theoretical experimental value is negative 1430. The theoretical is negative 1316, for example. These are just example. I've forgotten the exact number already. Okay. Okay. So now, why do I raise this issue is because why do I raise this issue is because inside here, when you have group 1, group 17 ions, they are mixed together. That means they have a large difference of the electronegativity. When you have large difference in electronegativity, the ionic characteristic is high. Compared to this one has a smaller difference in electronegativity. If you learn in the chapter 3 during semester 1 last time, one of the subtopic is talking about the difference of electronegativity and covalent characteristic. When you have small electronegativity, you have a high covalent characteristic. So when you have a high covalency, so that means the salt that the ionic compound that you form in here is not purely ionic. It contains some covalent character, and this will result the theoretical and also this one value will be different. Okay. Okay, so that is how you are going to describe for this one. Okay, so this is what a very small subtopic inside there that I hope that you take notes because sometimes STPM essay like to use that question. Okay, okay, so that is for number 13. Okay, so immediately we go to number 14, shall we? So the answer is A. Okay, which equation represent enthalpy change of formation? So very straightforward. The answer is B. Okay. So the problem of A is because A is 2SO2 plus O2 gives 2SO3. This is not standard. The moment that you use 2 mole is not standard anymore. Furthermore, this equation is more to describing the combustion of SO2. So B is the correct compound. C, what is C? Can anyone name for me what is C? If you look carefully, Mg2 plus aqueous plus SO4 2 minus aqueous give MgSO4 solid. This is the reverse of the enthalpy change of solution. Reverse of enthalpy change of solution. And then 2S gas plus 2Cl gas give S2Cl2 liquid. So inside here, what enthalpy change is this? Anyone? This is for atomization. But for this is for atomization. Yes. So atomizations of the compounds. So you must be very familiarized with all the enthalpy change. So please. Okay. Then finally, number 15, the reaction between iodine and chlorine in the presence of the produces iodine trichloride. Thermodynamical equation for the reactions are given below. You have I2 plus Cl2 give 2 ICl. Then you have ICl plus Cl2 give ICl3. Delta H is negative 88. What is the enthalpy change of formation for solid ICl3? So now you are given the two equations. I2 plus Cl2 give 2 ICl. Then you have ICl plus Cl2 give ICl3. So first of all, you need to know how to write the formation of the ICl3. So how to write the formation of ICl3? So you need half of the I2 solid plus 3/2 Cl2 gas if ICl3 solid. Okay? Now, based on equation 1, equation 2, what do you think we need to do in order to get to the desired enthalpy change of formation? So if you look carefully, instead of 1 iodine, we only need half iodine. Okay? And instead of 2 ICl, we only need 1. So In here, we divide by equation by 2 and we reform it as 1A. So when you divide by 2 already, so from the equation 1, you have half I2 plus half Cl2 give ICl solid. So delta H is positive 7 kilojoule. Then for equation 2, ICl plus Cl2 give ICl3 negative 88. So you can start to cancel in between things already lah. So what can we cancel? ICl cancel with the ICl. So overall, you can get half of the I2 plus half Cl2 plus Cl2 give 3 over 2 Cl2 give ICl3. So you sum up, it becomes negative 81 kilojoule. So the best answer in here is C. Okay. Okay, so that is how you are going to express for this one. Okay, so that is for number 15. Okay, number 16. Selected value of enthalpy change are given below. So you have the this energy of MgCl2, negative 2489. Hydration energy of Mg2 plus, you have negative 1891. Hydration energy of Cl minus, you have negative 381. What is the value of enthalpy change of solution for MgCl2? So you use the equation, MgCl2 solid give Mg2 plus aqueous plus 2Cl minus aqueous. So it is enthalpy change of solution is equals to hydration minus lattice energy. So you substitute lah. So negative 1891 plus 2 times negative 381 minus negative 2489. So press your calculator, you get negative 164 kilojoule per mole. Okay. Okay. So also in this chapter of thermochemistry, I hope that you all go and practice to draw Born-Haber cycle. Okay, Born-Haber cycle is extremely basic, and trust me, for the STPM semester 2, especially this is the first year of the new syllabus, right? So I have a strong feeling that lattice energy, the Born-Haber cycle is so basic that they will definitely ask this question. So, and in the previous trial examination, if you do my school's premier trial, we have also already given the Born-Haber cycle, isn't it? That is why for this technique, I'm not going to go for Born-Haber cycle anymore, because we have already given, you can see a lot of school also uses that. So please familiarize with the Born-Haber cycle. Okay, so for more information, if you need any help, you can ask your school teacher, right? Okay, so number 16 is A. Okay, so I stop for a while. So, sir, number Q, number 14, the formation of SO2, should I write S or S8? S can. S also can, no problem. Okay. Doesn't matter. In here, we are not going to stress S or S8. Okay. Okay. Doesn't matter. In this case, doesn't matter. S or S8 are both accepted in STPM. Okay. Okay, number 17. An aqueous solution of copper sulfate is electrolyzed for 1 hour using a constant current 0.42452 ampere. Graphite electrodes are used in electrolysis, which is not true about the electrolysis. So given to you, Faraday constant is 9650 coulomb per mole. So 1 mole of gas occupy 24.4 decimeter cube under room temperature pressure. Okay, so let's together calculate about the electrolysis using graphite as electrode. So at cathode, you have Cu2 plus 3 minus gives Cu. At anode, you have 2H2O plus O2, give O2 plus 4H plus 4E minus. So your current is 0.452 times is 1 hour, which is 3,600 seconds. So you use Q equals to IT. So you have 0.452 times 3,600. You get 1627.2. So which is A is true. And then actually, if you continue on, so inside here, because you electrolyze by using graphite, eventually the blue color will fade. Okay, so let's continue with the mole of the copper. So 1625, because you require 2 electrons, that means you use 2 Faraday. Okay, so divide by 2 times 96500, you get 0.00843 mole. So 0.0843 times 63.5, you get 0.535, which is true. Okay, and then in terms of volume, so now stoichiometrically, 4 electron is to 1 oxygen, right? Okay, so that is why your Faraday constant you also divide by 4, okay. So you get 0.00422 mole. So volume of oxygen is 0.0422 mole times 24,400, you get 103 centimeter cube, not 206 centimeter cube. So the not true in here is donkey D. Okay. So teacher, do we have to memorize this? To be honest, because there are certain years of past year questions that require students to know by yourself that oxygen is produced at anode for mainly the general electrolysis, except when you electrolyze a halide ion. And then for cathode, you always electrolyze hydrogen, except for those electropositive metals. So, macam mana pun cuba hafal sikit lah for the water in anode and cathode. So, if anode is the 2H2O plus give O2 plus 4H plus 4E minus, the cathode half equation for the water is 2H2O plus 2E minus give H2 plus 2OH minus. So memorize a bit, no choice. Because these questions are so common that we as a teacher, we often ask students to memorize a bit of this one. Because it is sometimes not given inside the questions. Okay, so you have to know by yourself somehow. Okay, sorry to say this. Okay. We have seen before. Okay, so question asked, teacher, if is it wrong if we wrote 2 electrons instead of 4 from copper? It's not true because it's 2 half equation is already written there 2. Okay, okay, can Okay, so we goes for continue number 18. Okay, electrolysis of bauxite in the molten cryolite produces aluminium at cathode and oxygen gas at anode. The volume of the oxygen gas at anode is less than the expected volume. So why is it that the oxygen decrease? Why? Because the oxygen gas will react with the anode of the carbon to form carbon dioxide. Okay, so this one you have to know. So that is why the graphite at anode has to replace from time to time, because eventually it will react with the hot oxygen that form carbon dioxide. Okay, so the answer is C. And then try to pay a little attention to this process called as the anodization. Anodization is also quite common in the previous old syllabus. Okay, so you try your best to remember a bit about the anodization. Where the anodization, this is the setup of the anodization. You have this one. When we say anodization, that means that the aluminium will act as the anode, and then the graphite will act as the cathode. Okay, carbon. And then your electrolyte is dilute H2SO4. This is where I said that you need to memorize that, because at cathode, at anode, what will happen? You shall have the 2H2O this one. So that's why, as I told you, sometimes you need to memorize a little bit things by yourself. Okay, and then so the anode, the oxygen in here will react with the aluminium to thicken to become the aluminium oxide. So that is how you thicken the aluminium oxide layer inside here. So for more information, please dive into anodization. Okay. Then number 19, standard reduction potential of the cobalt and ions are given below. You have CO2 plus 3 minus give CO, Fe2 plus 3 minus give Fe, Fe3 plus E minus give Fe2 plus, which is true about the standard reduction potential. A, Fe2 plus can reduce CO2 plus to become aqueous. So now your reaction is between Fe2 plus and CO2 plus. So when this is about spontaneity of a chemical reaction. In the spontaneity of a chemical reaction, once you already know that this is your reactant, inside your standard electrode potential in here, one reactant must be at the left side, another reactant must be at the right side. So this one, when you reverse, it will undergo oxidation. Then this one will continue to do reduction. So it must be a redox. Okay? So that's why we don't choose number 2, because both sides are at the reduction side. So cannot be. It must be one at the left and one at the right. So in here, your Fe2 plus CO2 plus give Fe3 plus CO. So inert cell is negative 1.05. So since inert cell is negative, we say that the reactant is non-spontaneous. Okay. So B, Fe has a stronger oxidizing power than cobalt, which is when we talk about higher oxidizing power or stronger oxidizing agent, remember this formula. We say that in oxidizing agent, if you want to determine the strongest oxidizing agent, look for the E naught value, which is the least negative or the most positive, then look at the left. Then if you are looking for the strongest reducing agent, you look at the most negative or the least positive, then look at the right. So in this case, we are talking about these three. Which one is the strongest oxidizing agent? So the strongest oxidizing agent is Fe3+. Okay, Fe3+ is the strongest because it is the most positive. Okay, and which one is the strongest reducing agent? It is the iron, which is the strongest reducing agent. Okay, so that is the key of how you read between oxidizing agent and reducing agent. And then the reaction between CO and also Fe2+ is non-spontaneous. Okay. Okay, so the best answer in here is donkey D. Okay. Okay, so with that, that is for question number 19. Okay. Okay, thank you, Mr. Go, for supporting. Please include the physical state in the oxidation and reduction half equation. Usually, in the half equation, the state of matter will be given to you. Okay, so when especially the last two chapter chapter 4 and 5 please always write the state of matter, especially when the question already give you the state of matter. So it is more important if you write. Okay, thank you for your support, Mr. Go. Please help me on guiding the students if necessary. Okay, thank you very much. Okay, so that is for number 19. Okay, okay, and then number 20, electrolysis of aqueous copper 2 chloride produces 1.65 gram of copper at the cathode. Which statement is not true? We are looking for not true about the electrolysis under standard temperature pressure. So A, platinum electrode is used. Usually we don't use platinum lah. We use we use graphite lah. Furthermore, platinum is inert to the chloride electrolysis. So that is why we don't use this one. Okay. Okay. And then the B, the blue color of the solution become faded. Yes. So because copper 2+ is removed. So B is correct. And then C, the quantity of electricity charge usually is used is 0.026 Faraday. So this one not yet multiply by 9650. You just replace by 1 Faraday. So mole of copper is 1.65 divided by 63.5. You get 0.26 mole. So stoichiometrically, 1 copper is to 2 electron. So the mole of electron is 0.052 times Faraday lah. Okay. So that is how you get to the 0.052 Faraday, not 0.026. And then D, the volume of the chlorine gas is 0.58. So stoichiometrically, because mole of electron is the same. So your mole with the copper also the same. So you also get 0.0260. So in here, what do I mean in here is stoichiometrically, 1 copper uses 2 electrons, isn't it? So 2 electrons form 1 chlorine. So that is why the since in here, mole of copper is 0.026. So here also 0.026. Okay, same. Because of this reasoning. Okay. So the best answer in here is C. Okay. All right. So with that, that is all for the 20 objective questions that I specially prepared for you. So these are actually all from the STPM past year questions. So hopefully you will be able to understand. And when we use past year question as this one, so it probably you will need to understand on how to get to all that. Okay. Okay, so that is for the objective questions. Okay, so if you want to take a break, you can go ahead and take a break. So we are going to the next part, which is section B. So section B is 14 marks. So in this section, we always advise students to spend 15 to 20 minutes in answering this section and try to make your answer be short and clear. Okay, and do not over focus in one question. So with the remaining time in here, just now I said 30 minutes on objective. So 15 to 20 minutes on the, just now I said what, 25 to 30 minutes on objective. So 15 to 20 minutes for structure. That means your remaining time is 45 to 50 minutes for essay lah. Okay, so you might want to spend a little bit more time on essay. Huh? Okay, so let's, without further ado, this one. 21 is a past year question. 22 is I take from the Raymond Chang's books. I don't know why it struck me because I don't know why it struck me. I just feel that I want to use these questions lah. So of course the question 22, the question number 22 is a little bit ridiculous lah. Sorry lah, Mr. Chiu punya tak tahu sudah fikir apa pun saya tak tahu. But I just wanted the students to know how to derive the Hiti. Okay, later you will see that. Okay, so 21, H2O2 decomposed to O2 and H2O. So the rate equation for the decomposition of H2O2 at 50 degrees Celsius is rate is equals to K H2O2, where rate constant K is 1.8 times 10 power negative 5 second minus 1. So the equation which relate the rate constant with activation energy is K 4.8 times 8 times 10 power 4.8 times 10 power of 8 epsilon of negative EA over RT in here. Okay, so in here, this is actually derived from K equals to A epsilon negative EA over RT lah, okay, which is the Arrhenius equation. Okay, number one, calculate the half-life of H2O2 at 50 degrees Celsius. So this one has 4 marks, you know. So teacher, such a simple question, why 4 marks? Now, in other words, sometimes you must read beyond all the marks given to you in here. Now you see in here, does the question tells you the order or not? The question does not tell you the order, right? Okay, so they just simply show the rate equation and then shows you the rate constant. And whenever they give you a rate constant, please be sensitive with the unit. And from there, you try to deduce the order of reaction is first order. Now there are 2 ways to tell the reaction is first order. First one is the rate equation. So this one is power of 1. So it's power of 1, then it is first order. Then the second way here is the unit of the rate constant. So the unit of the rate constant is S minus 1, then it's first order lah. Okay. So please, you must mention that the unit S minus 1 mathematically prove that the order of reaction is first order. So you must mention that. And then, do you see that the question also do not give you the equation? Write this equation. Yes, H2O. I'm now not showing you the answer scheme, no. I'm showing you technique of how to answer. Okay, technique of how to answer. Okay, so try your best to write as many as you can, even though it is structured. Okay, but because it's so big mark, 4 marks, and you feel that teacher is so simple, why don't you why can we write more? So these are the more things that you write in here. Okay, so either you write an equation or you say it's that S minus 1 is the first order lah. Okay, then you use the half equation, so T half is equals to 0.693 over K, or you write even ln 2 over K. So always remember in your calculation, always remember to have these 3 points: equation, substitution, answer. And in here, they uses 2 significant figure, 1.8. So your answer must also have 2 significant figure. So 3.9 times 10 power of 5, unit must be second. Okay, correct significant figure with unit. Okay, so 4 marks goes in here, 1 mark for the unit, 1 mark for equation, 1 mark for substitution, 1 mark for answer in here. Okay, and just in case if you worry that the marks is not there, you might also want to write the overall equations in here, because the question does describe to you what does the reaction take place, but they don't write the equation. So in other words, you have to write the equation on your own. Understand? Okay, so that is for A. And then for B, so calculate the activation energy at 50 degrees Celsius, which is 323 K, based on the equation K 4.8 times 10 power of 8 epsilon negative E over RT. So you must first, they give you the Arrhenius equation basic. Of course, they expect you to write the Arrhenius equation, the integration of the Arrhenius equation. Okay, so you must have ln K equals to negative E over RT plus ln A. Okay, only then you substitute. Now, when you substitute as exactly given to you. So they give you 50 degrees Celsius. They don't give you 323 Kelvin. So show how you get the 323. Okay, Okay, so log 1.8 times 10 power negative 5, substitute negative EA 8.31 times 273 plus 50 plus log 4.8 times 10 power negative 8. So press your calculator. So you have 83000 joule per mole, or simply 83 kilojoule per mole in two significant figures. So teacher, should we write positive, negative or not? It is understood that activation energy is positive but if you worry, then you put positive okay? So very straightforward mark. First mark is the derivation. Second mark is the substitution. Third mark is the answer here. Okay, and then you might also want to look into the graph of how do we plot the graph of ln k against 1 over t in the Arrhenius equation to calculate the activation energy lah. All right. So of course, actually there are more but this is some of the questions. So you cannot solely depend on my questions and then, okay, I already know Mr. Chu with your question. I can straight away go to exam already. No, you have to do a lot more exercises, okay? Okay, so that is for question number 21. Okay, so question, okay, so question in P equals to nRT kept as small letter. PV equals to nRT. Sometimes even the question themselves, they use a small p. But even if you write as large capital letter P, it also can. Okay. And then we will get mark for writing equation. You don't care whether got mark or not. Just write. Okay. Just write. Don't care whether they got mark or not. Just write. Your task is not to find the marks. Your task is to write correct answer. Okay. Okay. Then we go for 22. Consider the reaction between NO2 and N2O4 in the closed container. So you have N2O4 give 2 NO2 gas. So initially, 1 mole of N2O4 is present. At equilibrium, a mole of N2O4 has dissociated to form NO2 with the degree of dissociation alpha. Derive an expression of Kp on the reaction in the above in terms of alpha and also P, which represent the total pressure of the system. 3 marks. Then by rearranging the expression in A in the form of alpha, explain how the expression helps to predict the shift of equilibrium due to an increase in pressure. 4 marks here. Like I said earlier, that I don't know what struck me. So when I go through this Raymond Chang's book, so this question is quite interesting. So I put it inside my this one. It is not really calculation, but they want you to show on how you get that. Okay, so no need to press calculator. This one kind of question, no need to press calculator. You just deduce accordingly. Because in STPM, like I said, even in structure essay, not every question is like calculation. There won't be every question is calculation one. Won't be. Because calculation take a lot of time. Okay. Okay, so so now you have N2O4 give 2 NO2, your total pressure is P, and your degree of dissociation is alpha. So always use ICE method, initial, changes, and equilibrium. So your initial is 1 mole of N2O4, so no mole of NO2. So when you dissociate, so this one minus alpha. I use different color because this one is a dark color. Sorry for that. Kilo. Okay. So this one is minus alpha. This one, because stoichiometrically is 1 to 2. So that's why here plus 2 alpha lah. So at equilibrium, you have 1 minus alpha and then 2 alpha. So then after, because you want to calculate Kp, so you have to sum up the total mole. So 1 minus alpha plus 2 alpha, you have 1 plus alpha. So calculate the partial pressure. So the partial pressure of NO2 is 2 alpha over 1 plus alpha times P. And then for N2O4 is 1 minus alpha over 1 plus alpha times P. Okay, then you express into your Kp. So you have your, first, you must express your Kp, please, partial pressure of NO2 square divided by N2O4. Then you substitute lah. So when you substitute in here, so you have P square. So this one is square, this one is square. So P square over P cancel. 1a over 1a cancel in here. So you have 2a squared. This will give you 4 alpha squared. Okay. So you have 4 alpha squared multiply with the p here over 1 minus. Okay, see here is 1 minus alpha over 1 plus alpha. You have 1 more 1 plus alpha here. So you bring it down to here. So as a result, you get 1 minus alpha squared. Okay. So this is your final expression of the Kp here, okay? Okay, and then for phase 2, now you want to, from this equation, change to alpha. So your Kp times 1 over alpha square is equals to 4 alpha square P. So your then you substitute lah. So Kp is Kp minus Kp alpha square is equals to 4 alpha square P. So you move the Kp alpha square to here. So and then you take out the alpha square. So you have Kp equals to alpha square times 4P plus Kp. So this will make your alpha is equals to Kp over 4P plus Kp. So from here, actually they just want you to relate pressure with the alpha. So when you increase the pressure, you are decreasing the alpha. In other words, equilibrium will shift to the left. However, changing the pressure, the Kp will still remain constant. Okay. So as the pressure P increase, the degree of dissociation decrease as equilibrium shift to the left in here. Okay, so this is more to explanation on the position of equilibrium with the changes of the pressure in here, right? I to be honest, I also to be honest, I also sometimes not sure whether STPM will be crazy as me or not. So yeah, you never know. Okay, so just try out any possible question. Okay, so I show a few questions. So teacher is also fine to write 82.0. No. 82 is 82. Don't write 82.0. 82.0 is 3 significant figure. So no, we want only 2. So is it okay to use K equals to A epsilon negative A over RT? Cannot. The purpose is to ask you to derive the equation. That is the purpose. That's why they give you that equation. Okay. So we need to write our answer as 2 significant figure. Yes, 2 significant figure, not 2 SG. SG is Singapore dollar. Okay, so can we continue on? Okay, so with that is all for the structure. Any question for the structure in here? Can Okay. So if no problem, then we goes to section C, 26 marks. So you must answer both questions in this section, no choices. So you must be able to spend around 35 to 40 minutes. So around 18 to 20 minutes per essay question. So do your best to present in the essay as full content related to the question. Point form table mind map is allowed, but we don't advise unless you're really confident your answer. And then try not to write in the point form. And then one more thing, please, nowadays the answer is scanned. Please do not use pencil to answer. Even my own students sometimes also use pencil. Please do not use pencil. Sometimes you cannot scan the pencil writing. They don't give you the marks. So please write using pen, not pencil. Okay. Okay, are you ready? So let's go to 23. Nitric oxide react with molecular oxygen as shown below. 2NO plus O2 give 2NO2. So initially NO and O2 are separated as shown in here. So you have 120 kilopascal, 5.0 decimeter cube, and you have 150 kilopascal and 3.0 decimeter cube. A. Calculate the initial mole for both NO and O2 at 25 degrees Celsius. And when the valve is open, the reaction quickly goes to completion. Determine what gases remain at the end of calculation and calculate their partial pressure. Assume that the temperature remains constant at 25 degrees Celsius. And then C. Calculate the total pressure of the system at the end of the reaction. And then D. State the effect of adding neon gas into the system under constant pressure in here. Okay. Initially, I wanted to write 25.0 to make it 3 significant figure. So I'm going to highlight this first. The real significant figure for this question is 2 since I use 25 degrees Celsius. Okay. Okay, but my answer will show you 3 significant figure. I apologize for that. Okay. Okay, so you have plus 1, which is added to nitrogen monoxide at the pressure 120 kilopascal and 5 decimeter cube. And the plus 2, it is filled with oxygen at 150 kilopascal and 3 decimeter cube. So you use PV equals to NRT. Of course, expressing PV equals to NRT will give you 1 mark in here. So is 120 times. Okay, keyword in here. Substitute as exactly given to you in the question. One of the things that students always very lazy is to write the 2 decimal place behind here. Please don't skip this. This one is very important. You must write this. Okay. Okay, then times 8.31 times 298. So you get 0.24 mole and 0.182 mole. So 1 mark for substitution, 2 marks for answer in here. Okay, we can also accept if you write 0.24 and 0.18. Okay, So like I said earlier, my main purpose is actually asking students to write 3 significant figure, but because of the 25 degrees Celsius, we also accept 2 significant figure. And the answer is better in 2 significant figure, in fact, okay? Okay, so that is for A, and then for B. So now, in here, you already mix NO plus O2 to give 2 NO2. Okay, so you already mix them together already lah, right? So now, initially you have 5.00, you have 3.00, so your total volume in here is 8.0 decimeter cube in here. Okay, because stoichiometrically 2 to 1, so with only 0.24 mole of the NO, so NO is the limiting reagent. That means O2 is the excess. So how much is the excess O2? So you get 0.182 minus 0.121, you get 0.061 mole of RPX. And then stoichiometrically, because 2NO2, so this one minus 0.242, so this one you plus 0.242. So the remaining gas in here is also, oxygen and also nitrogen dioxide inside here, okay? Then you calculate using the partial pressure. So P equals to 0.061 times 8.31 times 298 Kelvin over 8.00 times 10 power negative 3, you get 18.9 kilopascal. And then for partial pressure of NO2, 0.242 times 8.3931 times 298 divided by 8.0, you get 7.49. So in here, if you write 19 and also 75 is correct, okay? Because like I said earlier, we focus on 3 significant figure lah, okay? Okay, and then finally for C, calculate the total pressure. So you use P total is equals to PO2 plus PNO2 lah. So your final answer is actually 94 kilopascal. You sum up lah, 19 plus 75 in here, okay? So that is how you are going to calculate for this one lah, okay? Okay, so with that, we have calculated B and C, okay? Okay, then we go to D. So what happens if you inject neon under constant pressure? So now you already injected neon inside here. What will it cause? So increasing neon will cause, this is a very important keyword, partial pressure of all gases decrease. Partial pressure of all gases decrease. Inside here only have O2 and NO lah, okay? So partial pressure of the O2 and all gases, just simply write all gases decrease. So as a result, equilibrium shift to the directions with more total mole of gas, okay? So therefore, equilibrium shift to the left here, okay? Okay, so that is how you are going to predict the O2 in here lah, okay? Okay, so that is for the number D, okay? Okay, so any questions for 23? Let's check. Okay, sir, is it required to change kPa to PA and decimeter cube? Okay, from decimeter cube to meter cube is a must, because when you use PV equals to nRT, your volume must be in meter cube. As for Pascal, be careful with the kilo. The kilo is 10 power of 3, so must change to become Pascal. Yes, okay? Okay, teacher, can we use pencil to draw one table? Like I said, try not to. I worry about the scanning part. If sometimes you scan, you draw using pencil, if the pencil is not good enough, then they sometimes cannot scan. So try not to use pencil, okay? Okay, so shall we continue? So, teacher, do not understand 23B. Boleh sekejap. Wait, I show you this one. So I hide your comment for a while. Okay. Okay, so for 23B here, the question now says that what happened after you react everything. So this is initial. So initial, you have 0.24, then negative 1.8. 0.182, sorry, 0.182, okay? So in here, stoichiometrically, because it's 2 to 1, so if you react with 0.182 O2, you require how many NO? You require 0.182 0.364. So do you have 0.364? No, you don't have. You only have 0.242. So in another word, this is the limited. Okay, so O2 is the excess here. Okay, so how many excess does it have? So because stoichiometrically 2 to 1, so you minus 0.121. Okay, so that's why you get 0.61. Okay, can? So I hope that I answered your questions. Okay. Okay, and finally we goes to essay question number 24. Standard reduction potential of the several half cells are given below. You have chromium 2 plus 3 minus give chromium, Fe2 plus 3 minus give Fe, Fe3 plus E minus give Fe2 plus, 2H plus 3 minus give H2, Ti2 plus 3 minus give Ti, and Ti3 plus E minus give Ti3 plus here. A. Identify the metal species which react with solid titanium to produce minimum value of the E cells in here. So write the cell notation. So when the question says identify the metal species, so try your best to describe. It is the chromium 2 plus chromium half cell. Chromium 2 plus chromium half cell. Okay. Okay, so from here, if you want to the minimum in here, so you find the one which is the least you want to compare to the solid titanium. So you must find the second one lower to it. Okay, so now this is titanium 0.163. So you must find the second most negative. Okay, so because this one is the most negative, okay, most. So you compare to the second most, which is the chromium here. Okay, so when you have this one and this one reacted, it will produce the minimum voltage. Okay, so which one is the maximum? The maximum is you react with this one. So this will produce the maximum. Okay, but the question wants produce minimum value. Okay, so it is the chromium 3 plus chromium. Okay, so as a result, you mentioned chromium 3 plus chromium. Okay, chromium 3 plus chromium 2 plus chromium. Sorry, chromium 2 plus and chromium half cell. Okay, okay. So you're right. The cell notation Ti solid and one line, Ti2 plus aqueous double line, chromium 2 plus aqueous one line, chromium solid. So state of matter is a mass, one line, this one is also a mass. And then calculate the EMF of the cell. So you use E naught cathode minus E naught anode. So negative 0.91 minus negative 1.63, you get positive 0.72. Okay, positive sign is a mass, voltage is a mass. So in chapter 4 and 5, thermochemistry and electrochemistry, because we are study under thermodynamics. So in thermodynamics, positive negative sign is a must. So please remember to put the positive negative sign here. Okay. Okay, so that is for number A. And then B, draw the schematic diagram for this one. So you draw, this is the voltmeter. Okay, inside here, you must use titanium. Okay, titanium, this one, and then label. This is the anode. Okay, this is the anode. And then sorry, I used a little bit brighter color. Okay, you have anode, which is made of the titanium in here, and then mix inside Ti2 plus aqueous solution, must label with concentration and temperature 1.0 mole per decimeter cube, 25 degrees Celsius. Whereas the cathode here, we uses chromium as the solid inside the chromium 2 plus aqueous solution 1.0 mole per decimeter cube at 25 degrees Celsius, and then draw the flow of electron. So the electron flow from the titanium to the chromium half cell here. Okay, the question also asks you to label which one is the cathode, which one does the cation go, which one does the anion go, isn't it? So cation goes to cathode, so this is your direction of cation, and then anion goes to anode, so this is your direction of anion here. Okay, just label like that. So with that, you'll be able to finish. By the way, this is salt bridge. Must label this salt bridge. Okay. Now this one, because I draw using AI, so AI beautiful diagram lah. Okay, but basically for students, you just draw cantik, okay already. clear enough for the examiner to see, then good already. So teacher, how usually we mark for this one? Complete setup, 1 marks. Label with the correct anode cathode, 1 marks. And then the salt bridge, everything is also 1 mark. And then in this case, you label the flow of electron, cation, anion is the 4th mark inside here. Okay. Okay. So teacher, sorry, wait. Okay, so we start from here first. So can you explain why you choose chromium? As I mentioned just now, we choose chromium is because the most negative is the titanium. So if you want the smallest voltage, you must choose to the second below than it, which is the chromium in this case. Okay, so that is why you chooses chromium. Okay. Okay, so sir, should we add 1.0 at the back? No need, no need, no need, no need, no need, no need, no need. Just write the titanium 2 plus aqueous enough already. Okay. Okay, thank you, Mr. Go, for helping. So if possible, use a pen throughout. If not, draw with 2B pencil or no need to worry too much. Just make sure diagram. Yes, 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 yes. Okay. Thank you, Mr. Go, for supporting. But like I said, nowadays they use scan one. I'm worried about the scanning quality if you use pencil. Okay, but should be okay lah. I don't know because I long time didn't mark already, so I don't know what is the scanning quality nowadays. Okay. Okay, so for temperature, can we write Kelvin? Boleh lah, 25 Kelvin boleh lah. Okay. 293 Kelvin. Teacher, 1.0 required to write cell. Yes, 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 yes. Okay. 你打过 required to write in the cell. Yes, yes, yes. You must write 1.0 mole per decimeter cube. Yes, yes, as I mentioned just now. Okay. Okay, welcome. Necessary to label the direction of movement of ion in the salt bridge. Yes, 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 yes. Okay, basically not at the salt bridge. Just mention the cation goes to the cathode and ion goes to the anode. Okay, already. Okay. Okay. Teacher, for chromium, can I just write chromium? Supposedly can lah. Supposedly can lah. But to be safe, we encourage students to write the chromium 2 plus chromium half cell. Okay. Okay, 24D later. We not yet finished discuss. Yeah, wait. Okay. Can? Okay, so this is 24B. And then for 24C, so the 24C, what is the question already? Solid iron is placed into an acid and the solid iron dissolved to form color solution. Explain your observation, 6 marks in here. So in here, the things is like this. So now you are dissolving iron solid inside acid. So your anode is iron become iron 2 plus 3 minus. Whereas your cathode is 2H plus 3 minus give H2. Now, use whatever information given inside the table. I know some of you are very good in memorizing. You go and even memorize this one. 4H plus O2 plus 4E minus to give 2H2O. I know some of you are very good in this. So no need to this one. No need. Just use whatever question give you. So the question give you this equation. Just use this equation, okay? So your overall is Fe plus 2H plus give Fe2 plus H2. So you have to prove your spontaneity so that you show that the reaction take place. So you use E naught cell equals to E naught cathode minus E naught anode also can, okay, as long as you are able to prove that the E naught cell is spontaneous since the E naught cell is positive, okay? The reaction is spontaneous. So what will you observe? So you observe iron will corrode and form green color solution, okay? And then you also have hydrogen gas evolve and the solution turns green here, okay? So these are the observations. So if I were students, I will try my best to write as maximum as possible here, okay? So where are the 6 mark? Determine anode cathode, 1 mark. Writing overall equation, 1 mark. Calculating the E naught cell, positive 0.441 mark. Stating that the reaction is spontaneous, 1 mark. So stating that, because the question also want to see what color, so green color solutions turns green, and then iron is oxidized, also 1 mark here, okay? All right, so with that, that is all for the essay questions that I prepared for you, and I'm so sorry because of the time constraint. I cannot explain everything, so I try my best to cover as much as I can. And if you have any questions, please ask in the Q&A questions in here, okay? So mastery is not memorizing formula, mastery is understanding the system. So good luck for STPM examination, okay? Okay, so now Q&A session. So feel free to ask any questions in here. And I want to apologize for this one. Okay, so sir, for 23D, isn't the loss of partial pressure by reacting with gas compensated by the neon O partial pressure by equilibrium shift to the left to compensate? No. Don't think that much, my dear. Just okay. So this is the thing, This is the thing, Okay. Back to the 23D just now. So I draw in here, I don't think in here. Okay. Okay, so imagine just now you have the gas of the NO and plus O2 give 2 NO2. Okay, let's say that this system is at equilibrium. Okay, so imagine that if you have a cake. Okay, so now you have 3 gases, correct or not? So imagine like this cake is divided by 3. So each of them get 1/3 of the NO, 1/3 of the O2, 1/3 of NO2, isn't it? Suddenly you go and add, on one more thing. Suddenly neon come in. You're adding neon under constant pressure. When you add neon under constant pressure, it's like the 4th person want to share this cake already. So because of the neon, so now same size of cake because pressure constant . So now you divide by 4 already. So now you divide by 1/4 NO, 1/4 O2, okay, 1/4 NO2. And because of the neon now, you still have to divide with the neon in here. So the partial pressure, do you see that? Partial pressure of each gas in here is already decreasing. So that's why Lee-Chatelier principle will suggest now partial pressure of all gas decreases. So in order to increase back the partial pressure, so that is why equilibrium will shift. At the end of the day, they still want the main character, which is NOO2 and NO2 to respond because they are the ones who are reacting inside here. Okay. So that is how you are going to figure it. Okay. Okay, then we go to the next one. So is it necessary to include reversible sign when writing equation for any equation? It depends on the situations. If we are talking about chemical equilibria, when we study rate, is rarely using reversible. Okay, how to explain? Chemical equilibria, Kc, Kp, and all this and that definitely is using reversible, yes. And then when you are deducing spontaneity of a chemical reaction is also reversible. So the rest of them is just one way. Most of the time is one way. Only when we express the equilibrium is reversible, okay? But the rest is just one way, okay? Okay, teacher, could you repeat how to mark the method of 24C? Just write everything there. First mark goes to when you write the iron is oxidized, hydrogen is reduced, or you write iron act as the anode, hydrogen ion act as the cathode, and then write the half equation, write the overall equation, calculate the E0 cell, telling that if the E0 cell is positive, reaction is spontaneous. Usually, when deducing spontaneity of a chemical equation, the 4 marks goes like this. The 4 mark goes to writing the half equation 1 mark, writing the overall equation 1 mark, then calculating the E0 cell 1 mark, and then based on the E0 cell saying that the reaction is spontaneous 4th mark, and then state the observation because the question was one observation 5th mark, and then state that what happened throughout the process. So iron is oxidized to form iron 2+. Okay, so that is the 6th mark here. Okay. Okay, so for all graph sketching, just better use pen or draw them out. For graph is a different case. For graph, you can use pencil You can use pencil for graph Okay. Okay, neon partial pressure. Thank you for answering alpha. So it's actually the label of energy level diagram. No need to touch the y-axis or not. Actually, touch or don't touch, does it really matter? I don't think so. It matters. Okay, that I don't think so it matters. But okay, when it comes to Born-Haber cycle, my dear, when it comes to Born-Haber cycle, when you draw the Born-Haber cycle, you must remember to label like this, energy in kilojoule, okay, then draw one line. Let's say you want to draw for NaCl, so you start from the zero, so you write there Na solid plus half Cl2 gas, give NaCl like this. Okay, now, a few key things that you need to know, take notes for this. When you draw the arrow, it must from one end to one end. You cannot write this. They penalize you if you write NaCl plus half Cl2. You draw like this, You draw this one NaCl. They penalize, actually. I heard from my friends. They penalize if you write on top of it. So you must reach the energy level here. So this one correct, this one not. Okay, and then you label this is delta HF. So the zero start from here, the delta HF. Okay, so that is how you are going to draw for the Born-Haber cycle. Okay. Okay, so for Bowman's distribution graph, is there any precaution that we need to take care of when we draw the graph? They rarely, they rarely ask students to draw Maxwell-Boltzmann distribution graph. Rarely. Don't think too much about that. I rarely see them asking you to draw Maxwell-Boltzmann. No. Don't worry about that. No. Okay. So in electrochemistry calculation, when calculate the time taken, should we take the decimal place? For example, final is 12.9, we take 12.9. Okay, depend on the significance question. If you see the question, like just now, our examples, I scroll back. Okay, like just now, these questions in here, you see that you have three. This can be two, this can be three significant figure lah. This is obviously three significant figure. Okay, this is also 2 or 3. So this is 3 SF, but this one is 2 SF. So we take the smallest significant figure. Okay, which is 2. Okay. Okay, so depends on the situation. Okay, teacher, the decimal place need to put at least 3. Like I said, look at the question. Okay. Okay, can I ask Nernst equation only can use under non-standard? Actually, it can use under. Usually, Nernst equation is definitely under non-standard because it is derived to calculate the non-standard condition. And try to memorize a little bit about Nernst equation. A very good. Sam Lok, you have helped me to remind that you need to this one on the Nernst equation, please at least memorize the Nernst equation, my dear, all of you. E cell equals to E naught cell, okay, minus 0.059 over N log concentration of the product, okay, over reactant. Okay, and in certain case, where let's say you are studying for but nowadays they don't have SHE, they took out the syllabus of SHE standard hydrogen electrode, non-standard hydrogen electrode but still if let's say it really come out because we don't know yet. So let's say if you have Mg solid plus 2H plus give Mg2 plus H2, right? Okay, so they will give you all sort of concentrations right here. So let's say in here you have 0.052 mole per decimeter cube. That means this is a non-standard. Okay, or they give you pH. They give you pH, so you have to anti-log it. Okay, so to find the concentration of H plus. Okay, so now back to this one. I wanted to highlight in the sense of when you want to express the Nernst equation, you should express as E cell equals to E naught cell minus 0.059 over N log concentration of the product. So Mg2 plus time partial pressure of hydrogen. So this one must also include, okay, over concentration of H plus square. Okay, so you must include this one. Must include. Okay, thank you very much for helping me. This one. Okay, so what do I need to add up to hit the calorimeter? Huh? When do I need add up the heat of calorimeter? I don't know which question you are referring in this case. Can you give me an examples? Teacher, for gas constant has 8.31. How to use? Oh, okay, good question. This one also is another good question. Okay, so nowadays in STPM, we have already seen it in the previous 2 years examination. PV equals to nRT. Okay, so there are two versions in here. If you are given R is equals to 8.31 joule mole minus 1 Kelvin minus 1. So your P must be in Pascal, your V must be in meter cube. Okay, so let's say if you are given in centimeter cube, you will have to times 10 power of negative 6. And if you are given in decimeter cube, you have to times 10 power of negative 3. Okay, temperature must be in Kelvin. Okay, so if it is degree Celsius plus 273, okay, then this is for R equals to 8.31. If you're given this R is 0.0821, 8206, the unit is liter atmosphere mole minus 1 Kelvin minus 1. Liter is actually decimeter cube. So in another word, your pressure must be in atmosphere, your volume must be in decimeter cube, and then your temperature similarly okay, so that is how you are going to apply for this one. We have seen that question already in the previous year STPM. Okay, teacher, do you have any spot? No, I don't spot spot you cannot spot anymore so many things to ask. How can I spot? Cannot. If you said, teacher, how to spot, everything come out. So for head cycle also need to put 0. At head cycle, I don't think so. Mr. Go, correct me if I'm wrong. Okay. So how to identify unit cell like ionic transition metal or alkaline simple cubic body center? This one you have to memorize a bit. This one you have to memorize a bit. You can help ask ChatGPT to help a bit. Okay. Okay. Sir, I would like to ask, when draw the energy level diagram, should I use the zero energy to replace? I don't think so. I don't think so. No need to put the 0. We only need to put 0 for the Born-Haber cycle only so far. Okay? Born-Haber cycle only. Okay? Okay, what else? For this one, you have no choice but to find a little bit on books and then look through. But to be honest, so far they don't really stress about. Only one or two times they ask about this BCC, body center cubic, FCC, HCP. HCP is hexagonal close pack, and etc. But like I said, don't think too much. Satu dua markah sahaja most of the time Okay. Okay, to be honest, I don't know how strict nowadays. And to be honest, nowadays STPM question year trend is more and more weird already. I think Mr. Go, you agree with me. Become more weird. So that is why we try to expose students to many type of the variations of the question, because any questions can come out already. If you have chances to expose to Mr. Yi. Mr. Yi's question. Mr. Yi's question sometimes he always come up with a very good question. That's why I really impressed with him. So you can also try to find for his questions. Teacher, do you have any questions relating to fuel cell? I think I have inside my module macam ada deh. Why? Okay. Okay. So when writing log in the equation, do we write as LG or log 10 or log LG enough already LG already. This mathematical expression. So STPM STPM chemistry we don't bother that much about mathematical expression. We actually we don't accept STPM chemistry don't accept mathematical expression like smaller than, bigger than. You use the symbol, this symbol you use this symbol you can please in STPM, when you want to say is that enthalpy change of the hydration is smaller than the lattice energy, let's say. We don't accept like this, cannot. You must say enthalpy change of hydration is less exothermic than lattice energy. So that is why the enthalpy change of solution is endothermic. For example, so we don't use this symbol anymore. Okay, this one we cannot accept. But STPM don't accept this kind of a symbol. Please. Okay. So I heard OH minus and NH have the right. Yes. This is correct. Thank you very much for highlighting this. Yes, OH minus now the negative must write at the O and the positive must write at the N. Yes. This is true. This is true. Okay. This is true. Okay. But I'm not sure or not, Mr. Go. I'm not sure whether now it's organic only or other subtopic because they sometimes change here and there. I also become confused, But so far organic is the one. Organic is the one that really stress this. Okay. In organic chemistry, to be honest, I mean Sem 1, Sem 2, I'm not sure yet. We haven't seen this problem. Okay. I mean, we haven't heard that they penalize because of the OH minus. But organic chemistry, yes. Organic chemistry, yes. They start to penalize already. Okay. Thank you, Mr. Goh, for helping. I appreciate your help because sometimes, Mr. Chu, nowadays, as I grow older, I tend to do a lot of silly mistake already. I become worse than already. Maybe I start to become senile already. So I still try my best to give you the best that I can. Okay. Okay, so now when we write concentration for Kc or other than EC, do you need to write OH minus? So far OH minus is accepted. We don't see they penalize in Sem 1, Sem 2. We not yet see they penalize in Sem 1, Sem 2. Don't see. We not yet see they penalize in Sem 1, Sem 2. Okay? Sir, in ICE table, should we put unit? If possible, put like initial bracket mole. Initial bracket mole, yes. Okay? Okay, welcome. Okay, so yes, that's all already. And thank you very much for staying with me until the end of the talks. And I apologize for the earlier on because I don't know what is going on with this laptop here. So thank goodness I got this spare one so that it's easy. So I hope that you all enjoy and benefits from it. So all the best. Good luck in your next week STPM examination. To those who miss it, the recording is always there. So later maybe I edit a little bit to cut through to the what we have go through initially. Okay, so I wish you all the best and good night and have a good rest. And be careful with the health condition. My students drama in the mom recently. So you all also don't get sick in this very important season. Okay. All right, so with that, that is all for our talks tonight. Good night, everyone. Thank you for listening. Okay, thank you. Good night. So I end already, I end, okay.